Okay, I'm gonna wheel it out and we're gonna give it a shot. Hi, I'm Gordon Jennings. I build these portable solar generators. I just finished a video on how I did this. It's up and running, and we're gonna teach you how to do that. Talk for a minute about inverters. As you see, I have several of them laying here on the ground. I'm gonna flip the camera around and I'm gonna talk about them for a minute here. An inverter is a device which takes 12 volts, typically 12 volt input, and it converts it to 112 or up to 120 volts AC output. And you can buy some really inexpensive ones off of eBay or Amazon. These are some cheaper ones that I bought, and they were $45 to $60. And there's what they call a modified sine wave. So the output of the inverter is essentially 120 volts. And some of them have different outputs. For example, this one has a 120 standard AC outlet. It's got 4 USB outlets. And on the side, if you look at the side, it's got the conventional cigarette lighter 12 volt output. So that's pretty versatile. And you can hook up a lot of things to that. This one has an LED display where this one does as well, but this one only has 2 AC outputs. So you want to look at the wattage that it has. These happen to be advertised at way over their actual running wattage. This one says it's 16,000 watts. Don't believe it. It's probably levels out at about 600 watts is all. So don't be lured into those. They also are a modified sine wave. I'll show you what that is a little bit later, but essentially they're fine if you're using things like a 2-prong outlet for a light or a fan or something that's uses just 2-prong. If you need something that's grounded and you need real reliability, something like a refrigerator or a laptop, or maybe if you're using the Starlink, then I would go with an upgraded, very nice inverter. And the one I chose to use, after trying all of these, was I pronounce it a Giandel. I'm not sure if that's the proper pronunciation, Giandel, or anyway, they make anything from a 600 watt all the way up to a 2200 watt that I've used, and they are a pure sine wave. So the sine wave that comes out of it is truly smooth sine wave. And these are actually the wattage that they show here is the wattage that's actually it will run at. So this one will run at 600 watts, and you can peak at about double that for just a brief period of time. For example, when a refrigerator's compressor first turns on. So I wouldn't mess around with these cheap ones unless you don't intend to use it for an important appliance in your home. Giandel inverter we're gonna hang from this strap right here. So what I do is I get these 3-inch T-bars from Ace Hardware. This happens to be, you see the Ace number there, or you can get the 3-inch from Home Depot. This Everbuilt T-plate. Here's the Home Depot information that you need. I've mounted the T-bracket in this vise, and then I take a mallet and I simply tap on it and bend it over. It'll tend to bend at a curve if you're not careful. All right, so if you bend it this way, it keeps this bottom part flat. So I need to bend it just a little bit more. So I'm gonna tap on that, and now that it's bent, a little bit more. It's about at the right angle I'm gonna need. So I'm gonna loosen this up, pull it out, and I'm gonna come over here and compare it again, and we'll see. Okay, you see that if I put it on here and I come over to the side and I look at it, it's almost exactly vertical. And so depending on the angle that you mount your panel at, you're gonna have to vary this a little bit, but it doesn't really matter that much. I just like it to be vertical. Got the two brackets bent to where they're almost the same. All right, so I'm going to go ahead and put these on the Jiandal inverter. These holes are already there, so I just put the bracket in there. Then I had to drill 2 holes down here to make it secure, and so now there's two on each side, and it makes it really secure. I use the flat head to give clearance for that grounding wire and for this black lead that goes to the battery, the negative lead. So that's what it looks like in the profile. Kind of mount it to the side a little bit to give me more room to plug the AC in and out over here. So I'm going to skew it over to the left. I'm going to put a bolt in the center there and a bolt in the outer 2 there, and that'll secure it. Okay, you see that I have the T bracket bent, and I have on the right one I used the 2 outer holes to mount it, and it aligns just right. And then on the left side I use the center one, and just the center one aligns with the slotted the slotted bar. And so I'm going to tighten those up, and then that'll be the mount for the inverter. Okay, I tightened the bolts down, and that's pretty secure now under. I have the cart ready, solar panel mounted, we got the charge controller and the inverter mounted, and now we're ready to put the battery in. When it comes to batteries, there's a lot of choices now. You can go with a traditional car battery, but you want to go with what's called a deep cycle marine battery, because you're going to charge it, you're going to discharge it and then charge it again and discharge it and charge it again. So a deep cycle marine battery is the way to go if you're going to get a lead acid battery. The new technology they have today is called a lithium phosphate, iron phosphate battery. They just say lithium phosphate. And it has several advantages over the lead acid. One, it's lighter. It uses a new technology. The typical charge discharge cycle on not a lead acid, but a lithium ion battery is about 300 to 400 cycles, discharge and charge and discharge and charge. So there's limited lifetime on those things. With the lithium phosphate, the charge cycles are around 10 to 15,000. So they're way more advantageous to use one of those. And so I bought one, it's called a cyclone bat. It's a mini, it's smaller than the normal, and I'll zoom in on and show you that. They're more expensive. This with shipping and taxes was about 190 bucks, which is pretty expensive, but you can see it's smaller than a traditional battery. When it comes from Cyclone Bat, it comes with this styrofoam plastic wrapped around it. So I use that in the standard Group 24 battery box that I get from AutoZone or off of Amazon or Walmart, wherever. And I use that to space it so it fits in there properly. And I use the packing material that came with it to fit in the bottom. And then I cut off the top part just to make a ring, kind of a rectangular ring that goes around it like this. And that fits down on the top of it like that. And now that'll fit at the bottom here. I'm just gonna slide this one on to show you how it works. I'm gonna get it in position. And then I have these Velcro straps that I got off of Amazon. You can cut it to a custom length. They come with a bunch of these little metal brackets. And then you cut it, and it's got double-sided loop and hook. And so you can make it any size you want. So I attach it to the battery straps, and then I bring it around here, come on the outside of this, and I'll cinch it down. Now the video that I'm going to show you, it actually, what it does is we use Velcro on the bottom here to secure it to this bottom plate. I haven't done that yet, so it's still loose here, but I just wanted to do this to show you how to hook up the charge controller and the inverter. The wire from the charge controller is coming back here, and I think I custom made this one, but I have red on here denoting positive, and then I have black on here denoting negative. And now what we have to do is make a couple cables that go from here down to the battery. It comes with these extra wires with the MC4 connectors on the end, and a lot of extra wire. So I cut it and I put the lugs on to fit onto the charge controller. And what that left me with is a lot of extra cable. So I had a lot of this extra cable. So what I did is I went to AutoZone and I just bought the 1/4-inch ring terminals, 12 to 10 gauge wire. There's the part number from AutoZone. And that's going to go on one end. And then on the bigger end that goes to the battery, you'll need the 5/16. They'll fit not only these lithium phosphate, but also the lead acid if you get the dual terminal marine battery. And so what I did was I took some of the wire and I measured it to go from there to there. And I crimped on the 1/4-inch on one end, and then I soldered it. Then I used a soldering iron and I soldered it. And on the other end, I put the bigger 5/16 lug on it, and I crimped it, and then I soldered it as well. So I have these cables, these jumper cables that I'm going to run from the battery to the inverter. One of the problems is that this G&L lug that they have right here, I took the cap off to show you, is slightly larger than the ID 1/4-inch of these lugs that I bought from AutoZone. So what I have to do is I have to take a rat tail file. That's my crimp tool that I use to crimp them on. I'm going to take a rat tail file and I'm going to file the ID of these connectors just a hair so that they'll fit on the lugs of this G&L inverter. Difficult to get in here, but you only have to do this once. And then I'm going to put the caps back on, and then we'll be ready to attach it to the battery. And then I'm routing the cable down here on I'm going to make it look better, nicer once I get it all installed with some tie wraps. But I'm going to route it down here and attach it to the battery. Got the negative on and tightened it, got the positive on and tightened it. And as soon as you attach it, that charge controller should light up and show you what the voltage of the battery is. And right now, it's hooked up and it's showing that there's no input coming from the solar panel. There's a button over here, and you hold the button in for 2 seconds and it switches to this tells you what the use voltage is. If you don't do it quick, it reverts back. I'm going to hold it for 2, and then what I'm going to do is I'm going to hit it again, and it's going to go to B1. I'm going to hold it in until it flashes, and then I'm going to go to B3. B3 is the type of battery that we need to, because this is a lithium phosphate. And then what that means is that this is it won't switch back and forth. And then I can actually turn off, if I hit it twice, it turns off the charge that shunts out to here. So now I'm going to roll it out in the sun and show you what it looks like now that we're complete. Okay, I've rolled it out into the sun. I put the battery box lid on, and other than a few cleanups with the wires and some tie wraps, it's ready to roll. And as I zoom in here on the charge controller, you can see that it's showing 13.5 volts, and it's showing that let me zoom in here, that the solar panel is now charging the battery. Lid is on, and now I have the G&L inverter. There's a little button on the side to turn it on, and you can see that the green light is on. I have plugged into that a power strip and a device called a kilowatt. Show you that. the G3 kilowatt, which shows the power coming out of it. You can see that if I zoom in here, it's 119 volts. Not very clear, is it? It's 119 volts. Maybe if I get it out in the sun. Nope, not any better. 119 volts. I can look at the amperage that's flowing and the wattage that it's taking. It's 8.2 watts. All I have is this. I have another power strip attached to it so that I could have this kilowatt in there. And I have a light, just an LED light turned on. If I turn the light off, you can see that the wattage will drop way down, less than 1. I'll turn it back on again. So this LED light only pulls about 8 watts. And so you can see that it's up and running and working and everything's fine. Now I'm gonna go get another fan. I'm gonna get another fan to plug into this that draws a little bit of current, and you'll see the difference. I hooked the fan up, a bigger fan. I got the light going and I got the fan going. And we'll see what a difference it makes on the amperage. If I zoom in here, you'll see that it's about 104 watts. The amperage is about 0.888, and the voltage should not change. Voltage is 118, and there's a cool thing over here where it shows the kilowatt hours. So you can leave it plugged in and run it for 24 hours, and you can see how many kilowatt hours you're going to need. Anyway, that's pretty cool. It's portable. Throughout the day you can change it and adjust it to point to the sun. The idea would be that you charge the battery continually until you need it, and when you need it, then the battery's fully charged, and a 100 amp hour battery, depending on the load that you put on it, will last several hours in a camping situation, or if you need emergency power, etc.